So our last method of simplifying will involve making use of some special trig limits and then some algebraic manipulation to turn some more complicated problems into something resembling one of these two special trig limits. Our first one is the limit as x approaches 0 of the sine of x over x, which equals. I'd like you to go to your graphing calculator, or if you also want, you can use the website Desmos, and I'd like you to type in the function sine x over x, and using the ideas from our very first day of limits, where we looked at graphs of functions and tried to estimate some limits, see if you can figure out what the limit is going to be as x approaches 0 on that function sine x over x. Go to the calculator, see what you can do. Well, when I type it into the calculator, let's see, sine x over x. Oh, by the way, make sure you're in radian mode. I probably should have said that earlier. But graphing this, you know what, this isn't the best window. Let me make it, I don't know, negative 5, 5, 1, negative 5, 5, 1, so I'm kind of zoomed in a little bit maybe. Oh, wow, yeah, looks like as x approaches 0, my graph is getting really close to a y value of 1. The limit as x approaches 0 of sine x over x equals 1. Oops, actually, I forgot to do the very first thing I should always do. I should always start by plugging in sine 0 is 0, 0 is 0, so 0 over 0, yeah, it gives me that 0 over 0 thing. However, by looking at the graph, we can estimate that this thing is going to equal 1. And I'll actually prove that it equals 1 a little bit later on. Actually, probably in the next video, there's just one other tool we need to understand why that's the case. Second one, and again, I'd like you to go to your calculator or Desmos and see if you can figure this one out. Limit as x approaches 0 of 1 minus the cosine of x over x. And again, if I do plug in first, cosine of 0 is 1, so 1 minus 1, 0 on the top, 0 on the bottom. Go to your calculator, graph this function, and see what it seems to approach as x approaches 0. Let's see here. 1 minus cosine x over x. I'm getting a graph like this. Sure looks to me like those y values are approaching 0 there. Limit as x approaches 0 of 1 minus cosine x over x equals 0, and limit as x approaches 0 of sine x over x equals 1. We're going to need to make use of these two trig limits to deal with some more complicated limits. For example, let's take a look at the limit as x approaches 0 of the tangent of x over x, which is not one of our special trig limits, but maybe I can do some manipulation to make it fit one of those forms. Anyone have an idea what we could do? Maybe you thought rewrite tangent in terms of sine x and cosine x. I'm going to say the limit as x approaches 0 of, okay, the top is the sine of x over the cosine of x, and the bottom is x. Why don't I turn this complex fraction into one with fractions in both parts? So I'm going to say over x over 1. And I can do some simplifying here. Limit as x approaches 0 of the sine of x over the cosine of x. Rather than dividing by x over 1, how about I multiply by the reciprocal to get that? This is the limit as x approaches 0 of the sine of x over x times the cosine of x. But notice over here, the limit as x approaches 0 of the sine of x over x. That limit is going to equal 1. I guess technically I could use my properties to say this is the limit as x approaches 0 of that sine x over x thing times the limit as x approaches 0 of 1 over the cosine of x. Convince yourself that if you multiply those things, you get this thing over here. You don't have to write it out like this. I just wanted to show you how the properties are going to work here. Well, I know what this limit is over here. This is 1. So I'm just going to get 1 times the limit as x approaches 0 of 1 over the cosine of x. Go and plug in your 0 for the x. we're going to get 1 over the cosine of 0. That's 1 over 1. And this limit is going to end up equaling 1. I want to show you a few other variations. And then in the homework, you'll try a couple of these kind of varieties. I'm not going to try to make them too much different than what I'm showing you right now. Let's take a look at the limit as x approaches 0 of the sine of 6x over x. It would be really nice if I could just factor this 6 out front, but sine doesn't work that way. You had all sorts of like double angle, triple angle formulas last year and stuff. Sine 2x is 2 sine x cosine. You can't just take a number inside and move it out front. So I have some other work I need to do. If I actually go back to my first limit, it actually says a little bit more than just the limit as x approaches 0 of the sine of x over x equals 1. To kind of generalize this, as long as the thing inside my sine is the same as the thing in the denominator, then that limit is going to equal 1. So, even though I can't move this 6 up front, what I want to do is get a 6x up top like I already have, and a 6x on the bottom. Well, how about I just multiply the denominator by 2? Wow, I don't know why I said 2. How about I multiply the denominator by 6? Which of course you're not allowed to do, but you could multiply the top and the bottom by 6. I'm going to multiply this by 6 over 6. Watch why I'm allowed to do this. This will give me the limit, as x approaches 0, of 6 times the sine of 6x over 6x. This piece over here, because it's the sine of something over the exact same thing, and both of those parts are going to 0, that piece is just going to be 1. This gives me 6 times 1. This gives me 6 for an answer. You're not allowed to move the 6 up front. So instead of doing that, I want to make sure I get the same thing inside my sine on top as on the bottom. So I'm going to multiply the top and bottom by 6. Up top, I'm just going to get 6 times the sine of 6x. On the bottom, I'm going to get 6x. I'm then going to focus on that sine of 6x over 6x, sine of something over the same thing. As long as that thing inside is approaching 0, which is what I have over here, that whole piece is going to be 1. 6 times 1, 6. Yes, I realize this is the same thing you would have gotten if you factored out the 6. However, you're not allowed to do that. That is not valid algebra. I would not give you credit on a test or quiz if you're doing something like that. Make sure you're using appropriate algebra. Let's take a look at this one. The limit as x approaches 0 of the sine of 5x over 3x. This would be really nice if the denominator was just a 5 over there instead of a 3, because then sine 5x over 5x, that whole thing is just going to be 1. But that's not what I gave you here. But I want the bottom to be 5x. So I'm going to do the exact same thing I did in the previous problem. I'm going to multiply the top and bottom by 5. There's another way you can do it with fractions. 5 is going to be easier though. I'm going to get the limit as x approaches 0 of 5 sine 5x. And in the denominator, let me say that that's 3 times 5x. Limit as x approaches 0 of 5 sine 5x over 3 times 5x. I want to see if you see what's going on here and if you can finish this off. That sine 5x over 5x thing, that's just 1. We're going to get 5/3 times 1. We're going to get 5/3. One last variation of this. The limit as x approaches 0 of the sine of 5x over the sine of 4x. This is not great because I have two sines. I also don't have like an x below this or like an x over that. here's what I'm going to do. I'm going to multiply the top and the bottom by x. And actually, I'm then going to write this in kind of a strange way. I'm going to say this is the limit as x approaches 0 of, how about I say it's this thing times this thing. The sine of 5x over x times x over the sine of 4x. Hopefully you can convince yourself that if you did multiply these things together, you'd get sine 5x over sine 4x, the same thing we started from. Now see if you can... Actually, no, I think we should probably talk through the rest of this. This first one, I'm going to multiply by 5 over 5. This second one is sort of like it's turning into the reciprocal of my first special trig limit. But if you do the reciprocal of this, the limit as x approaches 0 of x over sine x, it's just going to be the reciprocal of your answer. It's still just going to be 1. So it doesn't matter that we have like the x and the sine in different parts. It's still going to work out over here. So here, I'm going to multiply that top and bottom by 4. Now maybe take a moment. See if you can finish this one off. So I'm going to get the limit as x approaches 0 of 5 sine 5x over 5x times 4x over 4 sine 4x. That piece is 1. This piece is 1. You're going to get 5 over 4, and that limit is going to equal 5/4. The homework will involve some variations that look pretty similar to these, and I won't try to vary things too much.